Let's begin with the article number 30, if you're ready. Mukesh, what do you think? Have you gone through the article number 30?
Hello.
Yeah.
Sir, your voice is little low. So,
Okay.
is this
Sorry.
online or
Sorry.
offline?
So I'm here in the class, but I
Okay.
think there is some challenge with the audio. Is it getting better now?
Yeah, little better.
Or about this?
Yeah,
Little
it's
better?
okay for
Fair
me.
enough. Yeah. All right. Okay, great. So I'm saying, I mean, there's a lot of material to go through. Why don't we begin with article number 30? And this might be something that you would have already gone through. So who would like to explain what are the different metrics for it? Yeah, sure. Cannot hear me? Yeah, okay. I'm not getting that option actually. Where? Next to? Acha, yeah. Sorry. Yeah. Yeah. Can you see my screen, folks? If you can confirm. Online folks.
Not
Yeah.
yet, it's still
Sinchana?
loading. It's still
You're able
loading.
to see it on your side. Screen. Okay, great. Yeah. And how's the audio now? Is it better or about the same?
The share screen is still loading for me. I don't know about others. But...
Yeah, even for me, it's loading.
Okay. For you folks, Ashutosh, working. So might be some internet challenge, folks. Just give it a minute. Should come up. Might be the slow internet or whatever, right? So that could be a reason. Yeah, so that's okay. I mean, while it is loading, in my blog, we were looking at article number 30. So I was wondering if somebody would like to explain what those metrics are and what you've understood. And have you already worked on some of those? You have some understanding? Yeah. You want to start, Murugesh? Online people can hear Ashutosh or no? You, Murugesh is audible? Like what Murugesh is saying?
No.
No, not at all.
Maybe it will be good if you can connect also, but then when you're talking, I'll mute myself, right? So that it doesn't echo. Just a second, right? And you can also do that, Mahesh and Malkarjun. You can also connect, yeah? So that people can hear you. Eh? Reshare the screen. Achha. Why? What happened? Oh, is it? Okay. Not right.
It's still in loading phase. Share screen.
So this is on my blog. Actually, let me just give you the link. I'll share the link right over here in the chat window. Yeah. Not coming up, Sinchana. What happened? I mean, I don't know. I mean, can we just call then Jordan? I think there's some challenge here then. Anyone is able to see? No?
No,
No.
Load.
No, it's not loading for me.
Not loading up. Yeah. You want to take a look? Mm-hmm. Yeah. Already been shared. Oh, no, hold on. Yeah. It was there already, actually. No, it was there already. Yeah. So I think there's some challenge, folks, with the screen sharing. It doesn't matter. You can take a look at the article number 30, and Murugesh was gonna explain what we have, right? So I just will put the link there for you as well. And let's see what all you can share with me, because this is very, very important for any classification algorithm that we're going to look at, right? So it's very important that we understand all of these as basic fundamentals, and then we will try to do some of the algorithm. Yeah, Burgesh, you can try to speak. Let me just mute myself and switch the audio so that it doesn't echo. Device setting.
Yeah, it's visible now.
Now it's visible.
It is visible now? Okay.
Yeah.
Yes.
I don't know what happened. So just a second, I'm just trying to. Can you try to speak up now,
Yeah.
Burgesh?
Just a second. Yeah, the first one is confusion matrix. It's basically used for it is for evaluating the classification accuracy. Okay. The next one is ROC curve, receiver operating characteristic curve. In this, we do this is used for binary classification, and we plot like false positive rate and true positive rate here. And the next one is AUC curve, area under the curve, and this is used to this is the area under the curve of the ROC curve. It will like we plot it plots the graph in such a way that above nearer to 100%, nearer to AUC is 1. That is the best value. That is the best accuracy, and uh, that's it. And next is the accuracy, overall performance. Do it same, and precision. Uh, the metric. Precision, accuracy, and these are all like the performance itself to check the overall performance. And the next one is recall. Recall, identifying the true positive. It is used for identifying true positive out of total positive cases. Total true positive cases.
Is that it?
There's one more. F score is there. This is a harmonic mean of precision and recall metrics.
Okay, great. And have you already discussed this earlier on? Like, I mean,
Yeah.
what is the precision? What is the recall?
Yeah.
The last module in statistical analysis.
Okay, awesome. Okay, let's see. Anyone? Thank you, Burgesh. I mean, I think you've done a fairly good job, but not completely. I have understood in terms of what these things are, right? But let's see if somebody else would like to explain. Malkarjun, you want to try? We cannot hear you. I hope when Murgesh was talking, folks online, you were able to hear him.
Yes.
Yeah, I hope you can hear me now.
Awesome. Yeah, Malkarjun.
Yes. Here, audible.
So I was saying this beautiful picture, you have given a very good explanation, sir. I just shared the screen, and this is really, really good to understand the accuracy, precision, and recall metrics. So it clearly says basically we are looking at when you did a classification problem, the crux of it is when we did a classification problem, how accurately it is able to identify the positives and negatives. So if all positives are identified, all negatives are identified correct, then there is nothing as an error over there. Then we say accuracy is 100% actually. So all cats, there is trues and all dogs true. They are identified divided by the total number. That is really giving a 100% accuracy. But what we are looking at is sometimes it is making a mistake. That's what the confusion matrix is talking about, wherein it has identified a cat as a dog or a dog as a cat, and so on. So we're looking at the precision and recall. This is the additional matrix, and we almost, I think, almost understood in the last class. Also, we discussed it, but maybe it will require a little bit refining of what does it really mean in the practical application. Because as I read some articles also saying that when you are targeting the cost of it, and blah blah. So this is the metrics to look at. So I need a little bit refresh that a bit more. So
Okay, got it. Thank you, Mr. Arjun. Anyone else online who would like to jump in before I try to give you my
so I stop
explanation?
sharing. You can reshare.
Yeah, please. Yeah.
Yeah, can I go?
Anyone else? Yeah,
Can
please
I
go
go?
ahead. Go ahead.
Yeah.
Yeah, go ahead, Mohit.
So like confusion matrix is the matrix which give us true positive, true negative, false positive, and false negative in a chart in a matrix form. And if we go to ROC curve, is a curve which is typically used for binary classification, which is 0, 1, yes, no, like that. And it create the curve. The x-axis is false positive, and in y-axis is true positive. Is kind of curve. And area under the curve, like AUC, it's give like how the model is accurate, how much like it will give how good is the model if the area under the curve is nearer to 1 or 100%. Then if you go to accuracy is like that we need to calculate accuracy if what you given in the example, like how many cat and dogs are correctly identified by the model, like how many true positive and how many, like mainly it's how many true positive plus true negative divided by the total number of samples we have. For precision, it will give us like when when a model identify as a dog and how many times the model is right if it's a dog or a cat. In recall, we see like out of cat, how many cats like the model correctly identify if it's a cat or yeah. And the score or F1 score, it's like is the sum of or we can see it's the mean of precision plus recall divided by the yeah mean of precision recall, like true positive divided by true positive plus false negative.
Awesome. Yeah,
And
great. So I think
also
you.
is
Yeah,
like
please.
also I can say like there are two limitation to a is AUC curve, like area under the curve. It says like first limitation, it's can't use or applicable for multi-classification, it's for binary only. And second, I think it's like it's not it can't calculate lightly for a unbalanced data, I believe, right? If I understand correctly.
Right,
That's
right.
all
Yeah.
I got from through the blog.
Awesome. Great. Thank you,
Thanks.
Mohit. Anyone else who would like to jump in? Nothing new to add, Mahesh? Okay, great. So I'll just spend time talking very quickly, folks. My screen is visible, Inshina? No?
Now it's gone again. Just to remind you, so please do the Python, what is that, profiling when you have done.
Pandas profiling. Yeah, I will do that. Yeah,
Yeah,
thank you, Mohit.
Pandas profiling. Sorry, yeah, that's it. Thank you.
I don't know what is going on with the screen sharing, folks, but I'm sharing from my side, so not visible there on your end. So let's try to figure it out. Is it now visible?
No, it's not.
No, I'll ask Jordan to come there. Arti, I'm Rashmi. I call Jordan to come there.
Sure. Thank you. Sorry? Duplicate. Okay. Where is duplicate? Sharing, no? You can see the red one.
It's already duplicated.
Duplicate.
Yeah. But there's options there are also because that's
Where?
it is already selected.
Already selected, huh?
There are.
Is it visible, Ashutosh? Yeah. Okay, so I think it's just there is a delay. So my apologies. I'll try to minimize the stopping of the screen share, right? So That way you don't have to necessarily face it. So just to confirm, folks online, can you see my this
Yes,
screen
it's
now, this
visible.
Excel?
Yes.
Okay, great.
For me, it's still
So I will request all of you to mute your system so that it doesn't echo, right? So I'll just try to explain you what this matrix is, right, and what are main things, and then we'll be happy to take up your question. And then we will begin with some of the hands-on exercise for the day-to-day, right? So, like you said, I mean, this is what we call as a confusion matrix. So I'm going to try to draw, but sometimes it works, sometimes it doesn't, depending on the. Yeah, okay. So I think this is working as of now. So what I'm going to do is I'll just give you my 2 cents in terms of what this matrix is and how do we interpret this, what is the significance, and what really we should make out from this, right? So let's imagine that we are looking at this classification problem. That we have animals, 2 types of animals that we're trying to classify. We have dogs and we have cats. And in reality, because I know which type of animals, how many we have, we know that there are 70 dogs and 30 cats, right? And I built an algorithm, classification algorithm. We are good. I think there's just some delay in sharing it here. So then we built an algorithm to predict which animal is a dog, which animal is a cat, right? On this data that we're looking at. And based on that, we got a certain prediction. And let's say the positive class. So if you have a binary, we can call one as a positive, the other one is a negative, right? So for example, let's say you are building a model to detect who is a fraud, right? I mean, a customer walks in and you're trying to figure out whether the customer is a potential fraud or not. So the positive detection means that this is indeed a predicted fraud. Negative means not fraud, right? Similarly, if you're trying to, let's say, COVID detection, right? I mean, when the test came out as positive, we call it a positive, right? Otherwise, it's a negative. Same thing happens over here. So when the dog is detected, we will call it as a positive. So positive is dog basically, and negative will be cat over here, right? That's what we're looking at. So there are 2 things that you have to pay attention to. And I think when you do the confusion matrix in Python, the axes are flipped. So right now the x-axis is the reality, or what we call as a ground truth, right? This is your ground truth. And y-axis is the predicted values, right? So if you look at how to read this confusion matrix, so if I'm working off the reality axis, you can see that I am accounting for 60 plus 10, which is 70 dogs in reality. Right? How are you doing that? We are looking at this vertical line. How many cats we are accounting for in reality? 30 cats. I'm just going in the direction of the arrow, the red arrow, right? Now what we're gonna do is we will have the blue arrow, which is sort of like talking about the model's prediction. So let's see who can tell me how many cats model predicted and how many dogs model predicted. So just add up the total. So if you're going in that row, just add up the total. So I'll give you one hint, right? So this is 25 plus 35. So 35 is what model is predicting as the number of cats. And the 65 is what it is predicting as the number of dogs. So 65 plus 35 is 100. Similarly, 70 plus 30 is 100. So that's why, I mean, you can see that we are actually doing the same number of prediction, but a cat has been misclassified as dog and dog has been misclassified as cat. That's what basically generates the confusion matrix, right? Let's look into the couple of things over here. What is the correct classification? Correct classification is reality, it's a dog, and model is saying it's a dog. So this is the correct classification, which is in the green, right? That's a true positive. In reality, it's a cat. The model says it's a cat, and we have true negative. So if I look at these 2 cells, or I mean these 2 boxes, box number 1 and box number 2, if we add up this, that's total of 85. So the accuracy of the model is 85 out of 100, 35% accurate model. Correct? Makes sense? What is misclassified? Misclassified is box 3 and box 4. Box 3 is a false negative. Why is it a false negative? Who would like to tell me in plain English? So in reality, it's a dog. In reality, it's a dog, but the model says it's a cat. So it's a negative that model is saying, but we know that it's inaccurate. So that's what's called false negative, right? Similarly, what about box 4? In reality, it's a cat, but the model says I have identified a dog for you. So it's a false positive. So I hope this makes sense. So till now, everybody's on the same page. All good? All right.
Yeah.
Yeah. Okay, great. So accuracy number is clear. So now let's talk about what do we mean by precision and recall, right? And this is very important because they're not the same thing and it will be different for different models. And you have to pay attention to both of them because they are both important, right? One will be more important in certain cases than other, but they are nevertheless both important. So let's begin with the precision. What is a precision, right? Precision will work on the model's predicted axis. And in plain English, it sort of measures your model's accurate prediction. So in this case, model says that I have identified 35 cats, right? Correct? This row I'm looking at 35 cats and 65 dogs. Out of those 35 cats, which the model says I have identified a cat, how many are really cat? Anyone? 25. So the precision
25.
for the cat is 25 by 35. That's the precision for the cat. So precision works on the model's predicted axis. So when model is saying that I have identified a cat, how many times your model is really correct in doing so? So how many times model says I have a cat? 35 times. How many times model is actually right? 25 times. Why this is right? Because we know that this is actually a cat, right? But this is wrong because it's a dog, but the model says I have a cat. So the precision for the cat is 25 divided by 35, which is whatever that number turns out to be. Who would like to tell me the precision for dog?
60 by 65. 60 by 65.
60 by 65. Correct? Is everyone clear on this? What is precision? So precision works on the model's predicted axis. So when your model says, I have identified a fraudulent case, how many times your model is correct is what basically that precision is boiling down to. So it never measures the reality, it measures the model's prediction. So it works from the starting phase of what is it that my model is predicting and how many times my model is right in doing so. Mallikarjun, you look a little bit confused. Are you good? Good. Okay, folks online, any doubts, any questions from anyone? So that's, yeah. Yeah, it doesn't matter. Yeah. That it doesn't matter. I mean, so because right now what you have is a binary classification. You have only two classes, dogs and cats. You may have a multinomial classification as well. So what is the rating on the product? Very good, good, neutral, bad, very bad. So that, I mean, there's no positive, negative. These are just multiple classes because it's easier concept to just delay. I'm good. Yeah, I'm good. Sorry, what happened? That. Oh, okay. There's some technical challenge, folks. So we'll just come back to you shortly. Let's see now. Ashutosh, no? I don't know what is happening. Shall I restart the system or something? Might be. No, it's not refreshing. Shall I restart? Okay. Okay. BPM. Acha, that's BPM. No, it's okay. Okay, awesome. Great. Okay, let me try to write something and see if this gets refreshed on your end. So now can you see it live happening? Awesome. Okay, great. So I think it was a VPN challenge from my end. VPN slows down things, we all know. Okay, great. So any questions on the precision from anyone? Are we good? Folks online, can you hear me loud and clear?
Yes.
Yeah.
Okay, great. Yeah, so now let's talk about the recall. Any volunteers to explain what the recall is trying to measure? Okay, so I will give you my sense and then see if you have a better way of understanding or explaining, right? So the recall works on the actual axis or the reality axis. So for example, if I were to compute the recall for dog, that means how many total dogs were there in reality? Can you tell me how many total dogs were there? 70 dogs. So what recall says is from those 70 dogs, how many your model was able to detect? So it's more like a detection rate, right? So the recall for the dog will be uh,
Okay.
60 divided by 70. So from the total pool of 70 dogs, your model was able to detect 60 dogs. So the recall for the dog is 60 divided by 70, right? Anyone who can tell me the recall for cat?
25 divided by 30.
Yeah.
That is correct. So that will be 25 divided by 30 because we had 30 cats in the system. And from those 30 cats, 25 cats have been correctly detected by my model. So that's what basically it is, right? So I'll take a pause over here and see if this makes it more clear. Malkarjan, I know you had a question on it. I mean, are you more clear now in terms of what these are? You're muted, I think.
Yeah, I'm clear on that. So what is an ideal scenario is also I'm looking at. So ideal scenario would be accuracy should be 100 and the precision should be also 100.
100, yeah. That's correct, yeah.
Okay. And recall should be
100.
false. Recall false
All
also
of
should be
these,
100%.
all of these should be 100, right? So that's how it is actually. For the classification report or the classification problem, we are looking at the metrics which measure the accuracy or the prediction power of the model. They should be as high as possible. So, like I mean, precision, recall, accuracy, F score, ROC, AUC, whatever it is, right? I mean, all should be as high as possible, close to 100. But you should never expect to get 100%. Because if you're getting 100%, that means that your model is over learning, right, or overfitting the data. And we'll talk about that in a next lecture. But that's what it is, right? So that's basically a crux of the like confusion matrix and the classification report and all of that. I will show you one live report and let's see if anyone would like to explain what this is measuring. I hope my screen is refreshing on your screen. Sinchana, can you confirm?
Yes.
Ashutosh, yeah?
Yes, yes.
So let's say this is for Titanic. Have you worked on the Titanic data classification on Titanic?
Yeah,
You've done that already?
yeah. I practiced
You
Titanic.
have practiced, but the class hasn't done it. So we'll do that today, right? But let's say in Titanic, we had, I don't know whether this is Titanic or not. I'm just pretending it's Titanic, right? So we have people who did not survive and people who survived, right? So I built a classification report over here, and I have a precision and recall and F score and all of that. Uh, I wanted to understand what does recall of 0.58 would mean, if there is anyone who would like to explain. Recall of 0.58. And I just gave this question in the AI03 final exam to explain what these numbers are or what really this means. So it will be good, preparation for you to get ready for what lies ahead for you. What is 0.58 in plain English? Let's assume one is survival. People who were there in Titanic, they survived. One is survival, zero is non-survival.
So it's saying 50% the model is accurately calculating who are survived. Or like if it's saying like as as we know, recall is like the how much the model predict like true positive divided by the total number of sample we have for that
Mallikarjun, you
particular
want to speak
survivor.
on the phone? So I think anyone who is talking, just plug in your earphone because I think it's a blended model, right? They cannot hear you, or you cannot hear them. So just plug in your earphone, at least on one ear, like me, right? And the other ear is free for the class. And then let's see what we are actually looking at.
Can you
So
hear me or not?
I can hear you, but the others couldn't hear you.
Yes,
So
yes,
can
we
you
can
just
hear
repeat?
you.
so
Mohit, we can hear you.
so it says 58 percent actually. My interpretation would be something like the model is showing some 60 people survived out of 100, but in reality, actually less than 60 people survived. That's what I can read from the recall.
So the 58% close enough. The 58% Mohit and Mallikarjun will be like from the total survivals, my model was able to detect 58% of them. So if there were 100 people who would have survived that crash, my model is only able to detect 58% of them. So my model is missing out the 42%, right?
Okay.
So let me give you another example. Let's say I'm building a fraud model, right? In financial services industry, fraud models are very, very important. Does anyone know what is a typical fraud rate in a credit card portfolio? What will be your guess? 10%,
About 15?
15%? Okay. Anyone else? I'll give you some numbers. Pick one number, right? So less than 1%, less than 10%, less than 50%. What is the closest number in the fraud?
Less than 10.
It's actually less than 1%. So the fraud is not that prevalent in the credit card industry, but whenever it happens, it basically is a big one, right? So because you process so many transactions, right? Millions and millions of transactions are being processed. A large majority of them are non-fraudulent. So let's say you've built a model to detect the fraud, right? So recall has to be very good. Like, I mean, if there are 5 cases out of 1,000 cases which are fraudulent, my model has to detect all of them, right? So that's what the recall is really trying to figure out. So the recall of 100% would mean that from the total 5 fraudulent cases, my model was able to detect all of them. Similarly, this one says that from the total survival, my model was able to detect 58% of them, right? So if I take this number, 58% or 60%, and apply that to the 5 fraudulent cases, that means from the total 5 fraud cases I had, my model was able to detect 60% of them, or 3 cases, and 2 cases escaped, right? So that is not good enough. I mean, I would like to capture all of them. So I need to have a recall value of 100% so that none of the fraud cases escape, right? And then you can see if I build a model which is very high on recall, if you go back to the confusion matrix, that may also mean that you are looking at a model which is very high on false positive as well, that it is able to classify the negative cases as the positive as well, right? So some of those things will come in, but we'll talk about that more. Let's look into this 0.86. What does it mean? 0.86.
Sort of all this precision. Okay. Precision.
What the model is
I see. People who did not survive, yeah. No, the precision works on the prediction axis. Yeah. So try again. Yeah, no problem. You can, I think you're getting there, but you just need to think through it. Yeah. Anyone else while Murugesh is thinking through it?
Here that 1 is survived and 0 is not survived, correct?
That's correct. That's correct. Yeah. Nope.
Like I can I say?
Yeah, please go ahead.
Yes, yeah. I think precision shows like 86% are not survived means 86%
86%.
accurately the
Yeah.
yeah accurately the model predict like for the not sur like the people have not survived. Like I can say uh, it shows for not survive if
Okay, close enough.
I,
I'll just give you my
yeah, yeah
definition, right? So when the model says that I have identified a non-survival, 86% of the time your model is right. I know, I mean, it may seem like I was saying exactly the same thing that what you're telling me, but it's different, right? So I'm saying
yeah.
when model says that I have a survival or non-survival, in this case, the model says I have a non-survival, 86 times out of 100, the model is right. 14 times the model is not correct,
Yeah.
right? Similarly, the precision for 1 is 62%. Now tell me, what does it mean?
Like 62% times out of 100%, the model is showing like it survived. The person has survived. Like 60%
Yeah.
out of 100, it's showing like the person
Yeah.
they
So
have
that means
survived.
also, like, I mean, Murugesh, I think you have to plug in your earphone because people are not able to hear you, right? So when the model says that I have a survival, I've identified a survival or survived passenger, 62 times out of 100, the model is right. So that
It's
means
right.
what happens to the rest of the 38? That means model says they are survival, but they're actually not survival, right? And then
Survival,
you can
yes.
actually draw the confusion matrix in your head. What really does it mean, right? So this basically is the crux of what we have, and we will keep on touching on this topic multiple times because this is really important that you get the differentiation between a precision and recall and all of that, right? And accuracy is
Yeah.
not very reliable number. Can anyone tell me why this is the case? Accuracy is not very reliable. Why that is the case? In which cases accuracy will not work?
Uh, like in which case accuracy is not work in
It is not
classification model,
reliable.
you're
It
saying?
is not reliable. Yeah.
In maybe in multi-class classification.
Multi-class classification, right? But may or may not be. So I definitely cannot conclude that it's not gonna work.
when your data is
It may,
imbalanced.
yeah, that's
Like
the correct
when the
answer.
data is biased to one side, maybe
Right.
that
So
time.
when you have one class which is overly dominated, then the other class, right? Or when you have one class which is dominating the other classes, multi-class classification, accuracy is not very reliable number, right? Let me give an example. Let's say go back to the fraud example. Like I have 1,000 credit card customers, and from that 1,000 customers, 20 customers are fraud, and 980 customers are non-fraud. Even if I don't build any model, I just say everybody is non-fraudulent. What will be my accuracy? I'll repeat the problem. 1,000 customers, 20 are fraudulent, 980 are non-fraudulent. If I don't even build a model and say everybody is non-fraudulent, what will be my accuracy of the model?
It will still be 95, 98, something like that. It'll be very high
So
actually.
not something exact number.
20.
It's simple math. I mean, you're
20 out
overcomplicating.
of 20 out of 1,000, right? So this
The accuracy
98.
is going to be 98%. That's
98.
exactly right, Malkarshan.
Yeah.
Right. So
Yeah.
because I'm saying like, I just put everybody as non-fraudulent. Everybody has been classified as non-fraudulent, right? So that means my accuracy is 98% because 98 times I'm right. 980 customers are really non-fraudulent, but it's absolutely a bogus model, even though it's giving you an accuracy of 980. What is recall in this problem? Again, that is very obvious.
High recall.
High recall? Who says high? Again, give me the specific number. What is recall? Nope. So you're saying that, I mean, all my fraudulent cases have been detected. It's just the opposite. Because I'm saying my model, I didn't even build a model. And I says everybody is non-fraud. So am I really able to detect any of the fraudulent cases? You're not, right? Because the 20 fraudulent cases also have been misclassified as the non-fraudulent cases. The recall is 0. I'm not able to detect anything at all, right? So accuracy is 100%.
Right, sir.
Recall is 0. Sorry, go ahead. Somebody saying something?
Like, isn't it this certain cases where when you try to do the test train split and in your test data, those you have that particular data, but when you try to train it, you don't get that particular data. It's not able to predict it. So you basically recall your precision, F1 score goes 0 there.
Right, right. I mean, but we're not even talking, I mean, about the train test as of now. I'm saying just a simple baby example, not
Okay.
even building a classification model, just going with the definition of what is a recall and what is an accuracy, right? I mean, not even applying any of the train test or cross validation, nothing of that sort. Just a plain English case. Like, I mean, I have 980 non-fraudulent, 20 fraudulent. If I don't build a model and say everybody is non-fraudulent, let them all go as clean, right? What is going to be the recall? Recall is 0 because I did not detect any of those fraudulent cases, right?
In this case, the true positive means actually you detected fraudulent.
True positive is
Detected
fraudulent.
fraudulent.
Right.
So here we did not detect anything. So it is 0, basically 0 by
Exactly.
anything. So it gives
Yeah.
to recall as 0.
Yeah, correct. That's correct. Yeah.
Got it.
I hope this makes sense why the accuracy is not a very reliable number and why precision recall, they are much more robust because of the problems that you're looking at, right? And then AUC, ROC, all of them, they have the challenges as well because they're not necessarily well defined for a multinomial classification. They're more for the binomial and all of that, right? So I'll take a pause and see if any of these concepts are not clear to you or you have a different way of understanding and explaining. We'll be more than happy to hear it.
We also learned a little bit of this as a class imbalance, that
Right.
technical
Yeah.
word was taught.
Right.
We see when class imbalance is there. So in one of the models, we're looking at it as a initial data examination or visualization. We also need to pay attention for that. Ideally, it should be a 50-50. Then you have all good cases, but the COVID cases or those kind of things are the fraudulent, highly class imbalance, where some of these metrics directly the accuracy may not make a good sense at all.
Yeah.
But still, it would make sense to immediately look at the other metrics, right?
Precision
So
and recall are robust. So
Okay.
whether you have class imbalance, whether you have outliers, whether you have any other sort of data ambiguity or data skewness that you have, I mean,
Okay.
they will still be valid, right? Because they have a specific interpretation. Accuracy is like, a catch-all sort of thing. Like, I mean, if I have like, this, how accurate I am, it doesn't really mean a whole lot of things, right? I mean, it means when you have like 60-40 or 50-50 or even 70-30 split of the data, it may still be interpretable, right? But when you have 98 and 2% mixed class balance, then accuracy doesn't mean anything. It's absolutely the wrong thing to look at, right? And a lot of times people will just use a catch-all phrase, how accurate is the model? It doesn't mean anything. So you should ask, what do you mean by accurate of the model? I mean, are you really talking about the accuracy? Are you talking about the precision? Are you talking about the recall? Are you talking about the F score? I can tell you what exactly my model has, but I need to understand first what you're looking at, right? So that's the main thing that you have to be sort of like, clarifying.
Okay.
Can you just speak up in the system? I don't know whether everybody can hear you. Mahesh has a question, folks. We'll just try to get him
So
online.
the recall definition says identifying the true positive out of the total true positive cases. So in your example, it is 980 divided by 980, which is equal to 1, right?
The true positive over here is fraud, 20. You're building a model to detect the fraudulent cases, which are only 20.
Okay.
And if you put all of them as the non-fraudulent, you did not detect any of those 20 cases. Right? So that's why the recall is 0. If you built a model which was able to detect all 20 of them correctly, then the recall would be 1. Because we are saying that fraud detection is what my positive is. COVID detection is what my positive is. Somebody has rare disease, that detection is what my positive is, right? Not the method class. I hope this makes sense. Yeah.
But sir,
One
recall
question
is
came up.
Go ahead, Malkrishna first.
Okay. Earlier we thought this accuracy, accuracy is okay. Recall and precision are related to, let's say, the case 0 or 1 only. What I meant to say is, when we say even a precision recall, okay, recall for cat, recall for dog, and precision for cat, precision for dog. That's
Right.
what we see in this table. So earlier it was a little, we thought we will always measure only precision for the true positive kind of a case. Now this is a little additional learning over there. I think in the formula, when you say precision, so true positive and true positive divided by true positive divided by true positive plus false positive. So you have to replace them with the true negative divided by true negative and false negative. So then it will give you the metrics for the other category.
That's correct. So that's I'm actually not a big fan of true positive, false positive, true negative, right? Because for binomial classes, you can still get your head around it, right? But for multinomial classes, you'll just completely go berserk, right? I mean, what all we are looking at. So you should just look at this. For example, this is a multinomial classification. This is the MNIST data, right? Which is the digits, right? So, for example, I built a model to predict the digits, right, from 0 to 9. And then I know which is the actual digit that we are having. So, for example, who would like to tell me the precision for 0? It's all here. So that's the beauty about that. If you don't think from the true positive, false positive lenses, you can actually compute the precision and recall right here in this matrix. What is the precision for 0 digit from this picture? So it will be working from the model's prediction axis. So this is the predicted axis. This is the actual axis, right? So how many cases model is predicting 0? 187 plus 1 plus 2 plus 5. If somebody can do the math very quickly. Model is predicting how many digits are 0? 187 plus 1 plus 2 plus 5 plus 3 plus 2. Huh? 190. 200. 200. And how many times the model is right? Which is actually they are 0? 187 times. So the precision for 0 is nothing but 187 divided by 200. Right. Because all of these are the misclassification. The model thought that they are 0, but this one person or this one digit was actually digit 1. This was digit 2, right? So model got confused with digit 1 and digit 2 and misclassified them as 0, right? So they are misclassification. Similarly, 5 digits, which is over here, like basically the letter or the number 5, were read as 0 by the model, and that's again a misclassification. What will be the precision for number 6? Precision for number 6.
178 divided by
yeah.
Yeah, 178 divided by, correct. What is the denominator?
60, 186.
Nope. I think there is a math problem there.
Divide.
So you have to, so these are the digits which the model thought are all 6, right? So we'll work on this axis, So we are looking at the precision for digit
3,
6.
4, 5, 6, 7, 8. 16.
So 178 divided by 178 plus 1 plus 3 plus 1 plus 3, which is 8, right? So 178 plus 8 is 186. Or
186
did you say 186 only?
186.
Yeah, I said 186
My
only.
bad. I mean, I did the math wrong, right? So then 178 divided by 186 is the correct number.
186. Yeah.
Right. Okay, let's do one more, then we can move on, right? I mean, I think we can spend too much time just talking about this topic. What is the recall for 5? Recall for 5. Now I'm flipping the axis. And this could very well be your exam question, exactly the same picture, but I just flipped the digit. So now you have to work on this axis. So from the total digits which are 5, how many of those were correctly detected by your model? Let's see who can do the math.
157 divided by 190.
157 divided by 190. So 181. Okay, so I'm getting two answers from Mahesh is saying 181, and who do we have online who was saying 190?
Sandeep, I think I
Sandeep.
need to calculate one more.
190. Okay, so I have a third number also, 191, 190, and then you were saying Mahesh 181. Okay. So the math that you have to do is basically recall will work on this axis, which is how many of the digits 5s were identified correctly by my
Recall
model,
is
right? So which is 157 divided by 5 plus 1, 6, 6 plus 9, 15, 15 plus 2, 17, 17 plus 3, 20, 20 plus 2, 22, 22 plus 8, 30, 30 plus 3, 33, 33 and 157 plus 33. That's 190. So 157 by 190. I hope this makes sense.
82% of recall.
So that's the interpretation, right? So it basically the precision recall will work regardless of you trying to classify anything as a true positive, true negative, false positive, false negative. None of those things are required. You just need to figure out what is the correct classification and which axis recall goes, which axis precision goes. Right.
There is one maybe remark on there. The confusion matrix is printed based on what data we give. Right. So over there, by chance we flip, then all this will go.
The sklearn will generate confusion matrix in a particular way. I mean, this is, let's say I'm doing something by hand, so I can actually flip the axis, but the confusion matrix in sklearn will always be generated in a particular way. And we have to name the table in that way. And when you're looking at the data, you will be able to make out whether that is correct or not. Because let's say I have 170 observation in my test data where I'm doing the confusion matrix on. And out of those 170, 50 are the class 1 and 120 are the class 0. So when you are looking at that numbers breakup in the confusion matrix, you can be rest assured that these are the correct numbers. I'll show you when we come to the Titanic, right? So just hold on to that thought for a minute.
Okay.
But it will come in a particular way. It won't be flipped.
Okay. What I meant is, can I quickly share my screen?
Yeah. Yeah. Let's try sharing the screen. Yeah.
Yeah. So I was referring to this part.
Yes, I know.
Yeah, this is what I was referring to.
Now come down where you have your classification report as well.
See, this is what I was talking to actually. So the confusion matrix, when we generate them, so by chance, if I flip these two, then things can go bad.
It won't matter. I mean, the only, okay, you're saying how I actually order the arrays. Yeah, that would matter. Yeah, I see that. Yeah.
So I see classes as the first input and then test try as the other input. Then it will actually get reversed.
Right.
So that is one
thing. So you
thing.
have to pass on the actual first and predicted next. Actual first, predicted next. Whenever you're computing anything, otherwise it will be flipped. You're right. But then that will be also evident if you're looking at that. So come down if you have done the classification report.
Yeah. Then what we did is instead of trying to count them true positive, false positive, and all, I quickly looked at this way of treating it. So it says CF view, and then it will give immediately 0001 and 1011. So looking at some material on the web, so I made out true negative, false negative, true positive, false positive, and all of that, and then just built this formula in. And then anytime we can simply cut paste this, and then it can take all these metrics automatically. It can extract and give the precision and we have built those things, recall, and then F1 score.
Okay, so you're actually not even leveraging the packages which are there, but nothing wrong with that. But then you have to do these things by hand. I mean, and it will be a challenge if you're doing a multi-class classification. Right?
We did both. There is manual hand
Yeah.
calculation. Then down we also have that automated. This is a different example. Yeah. So maybe when we have those kind of probably to avoid confusion, we can straight away use the formula and then package and then directly print the thing. Okay.
And there are checks and balances you would have in place to really check whether you have flipped something, right? So you should not just go and blindly look at the report and then take it forward. But there are things that you can check just to confirm that you've done it correctly. I'll talk about that later on. Yeah.
Yeah.
Okay. Any other questions, folks, from anyone before we move on?
Sir, I'm just curious, like for a like we take the diabetes data set, the recall should be higher for that, right?
If you're
We
trying
should
to
focus
predict
on
diabetes, yeah, then it should be higher.
higher, right?
Yeah. Recall, precision, accuracy, ROC, AUC, anything for classification should be as high as possible. For
Okay.
regression, what do we measure as the, I mean, I don't want to confuse you, but what are the metrics that we use for regression? Anyone?
R square
R
mean.
square.
R square is
R square.
sort of like, not preferred way of looking at it, but other metrics.
Absolute adjusted R square.
Nope. I mean, forget about the R square, adjusted R square,
Okay.
any other metrics that you are aware of.
Mean square error.
Absolute.
P-value is also not the machine learning way of looking at the regression. Any other metric
For which one, sir?
for regression problem?
MAE, MSE?
That's correct. So we look into the error terms, right? So what is the predicted values? What is the actual value? And the difference between the actual and the predicted is the error. So for regression, whether we're looking at the mean square error, root mean square error, or mean square error, or mean absolute percent error, any sort of error itself says that I should be as low as possible, right? So for regression, the model which has the lowest error will be the preferred model. For classification, the model which has the highest precision, highest recall, highest AUC, highest accuracy will be the preferred model, right? Because they look at two different things. One is the classification report says how good I am doing the classification. And regression says what is the error that I'm getting, right? So those are two different ways of looking at that.
Can you just please repeat the last?
Right. So I'll just make up some maybe example over here. Right. So basically the regression models, and I'm getting this problem where I have to write slowly. The regression models have error as the model performance, right? Now this error could be measured in different ways, or there could be different metrics, right? So basically one is called whiteboard. Acha, color white font, okay. I have this one, so I cannot hear everything very clearly here because this is already plugged in, right? So mean absolute error, right? These are some of the metrics that we use there. Mean absolute percent error, MAPE, right? Or MSC. Or RMSC, root mean square error, right? But the point that I'm trying to highlight, Mallikarjun, is that they're all error. And error is what? Error is difference between the actual minus predicted, right? Or the y hat basically. So if you're looking at the error, ideally they should be zero in your best performing model. So I'm saying, these terms, when you're looking at the regression model, the model which minimizes these terms is the best possible model. Whereas the classification report gives you those which are favorable metrics. They are all of these are unfavorable metrics. So they should be as low as possible. The output from the precision or recall, all of those are favorable metrics, and they should be as high as possible.
it created a bit of confusion on the logistic regression actually. So we should remove that regression from the logistic word.
Yeah,
actually.
it's not a regression; it's a classification, right?
Yeah,
So it's
but
just,
usually they say linear regression and logistic regression. It goes
Right.
in the flow, but then it is very, it's not actually relevant calling
Right.
the logistics as a regression. So logistics is a classification problem. Regression is a prediction problem of
Right.
the numbers. Okay.
Correct. Yeah.
So in
So
the regression, we are looking at the errors, and you should target towards as low as possible. In the classification, we are looking at the favorable, so we should target towards as high as
that's
possible
exactly
on
right.
those metrics.
That's exactly right. So that's the the rule that you cannot forget, right? So classification as high as possible, regression as low as possible. The metric. Right? Okay, cool. So I think that's a good enough introduction to the confusion matrix and why we measure that and what are the benefits and so on and so forth. And as Murugesh was pointing out that F score is nothing but the harmonic mean, right? Harmonic mean is very simply put, if you remember your AP arithmetic progression, geometrical progression, right, and harmonic. So it's nothing but 2 times precision recall divided by precision plus recall. Now, why would we have the F score? Any idea? Why do we need the F score? Why not just work with the precision and recall? Because everything has to be done for a particular purpose. Why do we have it? Because we wanted to create one more metric, confuse you, or there is a better reason. When you cannot choose, when you are equally agnostic to precision or recall. So you're saying, give me a model which basically optimizes both precision and recall. So then I'm going to look at the F score. When I'm actually more interested in the recall, then I really don't care about the precision and the F score. I'm actually building a model which is going to optimize the recall value. Similarly, I need to do for the precision, right? So it just depends on what business use case you're looking at and which metric is more important for you. And that will dictate whether you look at the precision, recall, F, or you look at something else. That's the rationale behind that.
So is it like the F square, the F score value is for comparing the performance of two different models?
You can also use the precision to compare the performance of two different models, but F score is more for when you want to balance the precision and recall together. But you can use any of the metrics for doing a comparison.
Okay, I thought like it is equal to your adjusted R square which we use.
No. The R square and the P value, all the things that you've gone through in the regression, they're not necessarily very applicable for the sklearn library, right? Because they're more statistical in nature. Machine learning libraries are more optimization problems, right? So they will try to figure out the way to minimize the error. They don't necessarily say P value, I'm on this tail or that tail. Those concepts are not even valid for the machine. Those are more statistical way, whether this is significant and how significant that is. None of those things are applicable for the sklearn library. I mean, they're more like in terms of the minimization or of the optimization function. Optimization could be that I want this value to be as low as possible or this value to be as high as possible. That's the optimization, right?
Okay.
Okay. Any other thoughts, folks, from anyone? Any other doubts? So we just covered the article number 30. Sorry, go
So
ahead.
all the p value related, most related statistical modeling related.
Yeah.
Okay, when we look at chi-square test and 2T test, A/B testing and all.
Yeah.
Okay.
They're all statistical. Machine learning is not statistical. I mean, even though it's learning from those concepts, but I mean, they're not necessarily like apple to apple comparable set of parameters that we're looking at. Machine learning is more to optimization problem, right? And when you're looking at the deep learning, that goes even the next level, which is talking about, I mean, how do we really get the function or the predicted values as close to the ground reality as possible. And then you lose a lot of insights in terms of how it is doing that, what function it is using, what is the shape it is assuming. Some of those things are completely missed out in the deep learning.
Okay. Could you please let me touch upon the parametric, non-parametric, and machine learning and statistical? How do we stitch all these four words up?
Okay, sure.
In a relation.
Yeah, definitely. And I think that will be a good introduction to the decision tree as well.
Okay.
Yeah. Right. So statistical approach of model building is when you had R square, for example, in the regression, right? Or you had p-value, right? All of those things are more statistical based approach. R square is like, from the total variability in the model that I have, how much of the variability can be explained by my model, right? And similarly, you have the statistics like F score as well, right? And so on and so forth. So you have these which are more valid for the statistical testing, right? Not to say they're not important, but not in the sklearn library, not in the machine learning library, right? I mean, they're all important when you're doing contingency tests, for example, or chi-square test, right? Building a model from the R square point of view. So the typical regression model, when you're building from the statistical point of view, you will look like this. For example, let's say I'm building a model for predicting the house prices, and we will have beta naught as the coefficient, beta 1 x1, beta 2 x2, so on and so forth, right? These are the coefficients for different parameters, right? And you'll have a p-value over here, p-value for this, p-value for this, right? So on and so forth. And that p-value tells you whether that term is significant or not in the model, right? So if the p-value is less than 0.05, which is the alpha, then you know that term plays a role in the overall model, right? In machine learning, you don't do any of this, that this term is significant or not, right? So what is machine learning trying to do? Same problem, exactly the same problem. It doesn't give you any p-value, so on and so forth, right? It will say the MAE of this model, mean absolute error of this model, is 2.3, right? Another model you build, that will be 2.8, right? A third model that you build will be 1.1. Without even caring about which term is significant, not significant, all of that, machine learning will say, choose this model which is giving you the lowest possible error. That's the. So we don't have that individual p-values, R square, and stuff like that we're looking at. We're choosing the model which is the best performing model, looking at this yardstick, and the yardstick is MAE, MAPE, RMSE, any of those metrics that you talked about, right? So that's one that we're looking at. Now coming to your parametric, non-parametric, which is a very, very good point, Mallikarjun. Parametrics are the methods which assume a particular relation. So when we're looking at the linear regression model, it says my y is linearly correlated to my x's. Sorry, x1 here. So they are a linear function, right? So when I change x by a certain amount, y will change by a certain amount, right? So it also means that they are assuming that the relation between x1 and y is linear in nature, right? So the points could be like this, points could be like this, points could be like this. But if I have, a shape like this between the x and y, your linear regression model will not work because it's failing that assumption that I have a linear relationship, right? So as long as there is any relationship at all, the non-parametric method will say, I don't really care whether it is linear, non-linear, what sort of shape you have. So this is a typical algorithm where the non-parametric method, like a decision tree, will come in and say, I can gladly solve this problem for you. But a linear regression model will not be able to work on this case because linear regression is a parametric. It says, I am linearly correlated to X, or the Y is linearly correlated to X, which may or may not be valid. So that's why you can see these are very, very limited application models because they assume certain relationship between the X and Y. And certain times they're going to be valid, other times they're not going to be valid. So that's why more robust methods like a decision tree or random forest or ensemble techniques will be more robust for a variety of different data. I hope that answers your question.
Yes, certainly. If decision tree, for example, can handle both linear and non-linear, so we can use that for all kinds of problems.
Yep, that's correct. That's correct. Non-parametric doesn't say that, by the way, if you are linearly correlated, I'm going to fall apart. I mean, it says, I don't care what is the relationship. As long as there is any relation between the X and Y, I will be comfortable doing that problem solving for you. Linear regression says, no, it has to be a linearly correlated variable to the Y. Then only I can do that job for you. The moment you violate that assumption, you will get into the territory where the model is not necessarily the best fitting model. Right? So that's why you can see most of the problems in the real world are not solved by a linear regression problem, for example. Right? They may be simple, they may be interpretable, they may be quick to implement. All of those merits are there, but most of the real world problems are non-linear in nature. Right? So you cannot say that as you grow higher in the years of experience, your salary will continue to rise, right? Maybe, may not be. After a point, the salary will start to come down as well because you're approaching the retirement and all of that, right? So versus linear regression will say, okay, when you were 45, you had 10 lakh salary. When you're gonna be 65, you're gonna have 20 lakh salary because assuming a linear relation, right? That is not valid.
Okay. Okay. A little related question is the non-parametric or the decision tree kind of things can be applied for both the classification as well the number prediction problem, right? So a fraud or non-fraud, or what is the price?
Absolutely.
What is the price given these conditions? Both problems can be solved by using.
Can be solved, yeah. So decision trees, random forest, support vector machine, any of these techniques are basically suitable for both regression and classification. Awesome, great. So folks, let's do the, sorry, go ahead.
No, I'm saying like, so it doesn't matter for a non-parametric algorithm, like if there is a relationship between, or there is no relationship between independent variable, right?
That's correct. That's correct, yeah. Um,
Okay.
you can still get the feature importance, but you will not get a p-value. And we will do some hands-on demo, Mohit, when you get to see which variable came out as important versus not important. But it won't give you the statistical test and stuff like that.
Okay. No, I just want to like find a differentiation between parametric and non-parametric
Yeah.
algorithms.
Non-parametric means that it doesn't have any baggages in terms of the assumptions that it's carrying with it, right? So it can be any relationship or it can be no relationship. You can still use the non-parametric methods. Versus the parametric methods, you have to follow a particular relation with them, right? What is the relation for a logistic regression? Can anyone tell me? What is it that it assumes?
Logistic regression.
Yeah. So it assumes that the this one, which is the odds ratio. So basically, you are predicting the probability only to your point, Mallikarjun, that it's a regression, but ultimately you're predicting the classes because it's doing this conversion, this transformation, which is called a logic transformation on the probabilities, right? So it
Log
is what we call as
transformation.
a logic transformation, which is nothing but log, natural log, basically log on the base of 2 of this ratio, which is called as odds ratio, right? So I hope you have gone through this, right? In the logistic regression, anyone remembers? No, or this is a brand new concept for you.
We had just had a trailer of this, actually, this
You just
particular
fit the model.
equation. We looked at the sigmoid function and all, but
That's correct. Yeah, the sigmoid, right? Yeah,
same thing. Okay, okay. Then we looked at it.
yeah. So it's basically the natural log of this odds ratio, and that's what basically makes a linear function. So ultimately, you're still assuming that the logic function is linearly correlated to my variables, right? So this is the equation for a logistic function, right?
Yep.
Versus decision tree, which will say, no, I don't really care about the equation. I will just try to minimize the impurity for you. When we talk about the Gini entropy, that concept will become clear for you. It doesn't assume this equation. Let's say I am not follower of any equation. I'm just gonna try to minimize the error for you or the impurity for you, right? Okay, great. Any other questions, folks? Now let's shift gears. If you don't have any questions, because Panda's profiling wasn't working for a lot of you last time, so we'll see whether we can make it work now. But before we go there, any other last questions on this topic?
I still had one question, but I'm not sure if
Yeah, go
it
ahead.
may time permit. I was looked at in most of our problems so far, what we have dealt and the algorithms or the approaches that we have made. Well, we looked at one final outcome. For example, in the house pricing predictions, we're looking at tell me the price of it, given all these conditions. or in the other case classification true or false, or multi classification it could also be, maybe in the decision tree when we go there. But how do we handle the problems wherein the end result I want two dependent variables, in terms of two dependent variables? uh, I can give example in my own domain, but I'm not able to give an example in the real
Sure, yeah. Own
this
domain is
thing.
great. Yeah. Why don't we talk
Okay,
about that?
okay. So when we look at a circuit performance, so given various inputs to the circuit, we're looking at, tell me what is the time and what is the power this circuit consumes.
Mhm.
So can any model predict both of them? The time is one parameter, and which is dependent on a lot of input parameters, and the power.
Mhm.
Time, or we call it a delay, uh,
Right,
delay and the power. So they
right,
are little inversely proportional. Like if it is
right,
very fast, it consumes high power, and it's very slow, it consumes low power. You can say still, yeah,
right.
directly proportional. So I want to predict both these parameters given this set of input conditions. So all the models that we have looked at, they're basically looking at, okay, give me all these conditions, I'll tell you what is the outcome. So how do we handle this delay and the power kind of a problem?
Hmm.
So what would work with ASM?
Let's hear from the group first. Any thoughts? How can we address that? Online folks. I mean, I hope you heard Mallikarjun's question that he wants to optimize or basically modulate for two dependent variables simultaneously. What could be the hacky way of doing that? Or what could be a simpler way of doing that? And I mean, there are, of course, models which will do the two dependent variables simultaneously, right? I mean, it just depends on how you're actually framing the problem, like stacked ensemble models, where we can do it. But there's a simpler way of doing that as well. Anyone has any thoughts, intuition behind that?
See, one
Can
brutal
we
way of doing that is do two separate models, feed them, and get the timing for the same input. You get the power.
You could do
Uh,
that, yeah, which is two independent models. But another way, you can always define your dependent variable that way. So, for example, your dependent, I mean, what will be the ideal situation? I'm just making up something. Let's say you want factor 1 to be 20 and factor 2 to be, so factor 1 to be 20 and factor 2 be 10, right? So you can say, okay, I'm looking at a ratio of these two. So the ideal ratio for me is 2, right? So if I take that 20 by
okay.
10, so I can always define my dependent variable, which incorporates the relationship between them, right? So what will be the value that you're looking at? So for example, for the same observation, you have dependent variable 1, you have dependent variable 2. Depending on what you know about the business, you can define a third dependent variable, which basically incorporates 1 and two's relationship, and then model for the third one. So that's another way of doing that. I hope this makes sense.
Actually, that sounds yeah, very good. I didn't think of that. Okay.
Yeah.
So that way,
So
even if there are more
yeah,
than one or two variables or three
absolutely,
variables, we can arrive at a
absolutely.
ratio.
Right.
And even in some of the optimization problems, we can target the ratio is what we want to maximize, minimize, or whatsoever. We can do
Right.
that.
Right.
Okay.
Because let's say, just to give you a simple example, let's say you're trying to buy the house which is giving you the best possible value, right? So value could be the absolute dollar that you're spending. The value could be also defined. So you want to optimize for, like, I want to pay least amount of dollars for the square foot of the house. So you could build a model which predicts the price and the square foot, or you can say that I want the model which predicts the highest or the lowest value of the per square foot, right? And that is what the best value house for me is, right? So that is a clever dependent variable feature engineering, and that will work. Right? Awesome. So, folks, pandas profiling. How many of you have working or have done earlier on? Ish? No, hasn't worked for you. Okay. Anyone has it working on your system?
Right.
You have it, Malkarjan?
Yes, sir, it's working in my system. Yeah.
Okay. Yeah, I think there are some dependencies which are there. So I'm just gonna pull up my notebook and I'll show you. By the way, I'm gonna work on Google Colab. So for Jupyter Notebook, you may have to do certain tweaks, right? But I'll just walk you through how this is working. And I mean, do you want to share your screen, maybe what you've done, if you've done in the Jupyter Notebook or Colab you have done?
Jupyter Notebook, sir. I can
Okay.
run that code in Colab as well.
Okay. Do you want to share your screen very quickly and walk us through what you've done if it is working for you? I mean, can you just confirm first whether it's working, and then we can take a look.
Let me open that first.
Yeah. Otherwise, I will show you, you know, what I did some time back, and hopefully that would work for you. But we'll see whether that is the case or not.
So it will work same for Jupyter Notebook.
It may not be. So that's what we have to confirm. But I was waiting for somebody who was able to make it work in the Jupyter Notebook environment. Colab obviously will be slightly different from the Jupyter Notebook environment. Yeah.
So the question is here is that it's definitely working, but for the other people who is not working, it is just that we'll have to print out what all the versions that we have used for
Exactly.
it make
Correct.
it work.
It's more
They'll
about the
have to,
version.
they'll have to just ensure those packages are there with them.
That's exactly right. So it's more about the versions that you have to have. In this case, what I had done is, and I have to first confirm whether it is working indeed, because it has been some time since I last run it, right? But you have to do the upgrade of pandas, upgrade of pandas profiling. Both packages need to be upgraded. Once you have done the upgrade, you will see some sort of like errors over here, right? So it says, you know, this is not compatible or whatever, right? And if I remember correctly, um, in this one, maybe I haven't done it, but somewhere else, I mean, I needed to downgrade one of the packages as well, because pandas profiling is slightly tied to one of the models over here. But let me just see whether I am able to run this one at a time, and we'll take it from there. But I think, I mean, if I remember last time, you were able to figure out the exact package which needs to be installed, right?
Yes, sir. I guess we did this in last module as well, right?
Right.
Uh,
But some of the folks are saying that it's not working for them.
we had to, if I remember correctly, let me just open that, recall that part.
And I mean, how come you're not there
I
in the
mean,
class today?
So I have a leg injury, I can't walk.
Oh, acha, acha, what happened?
So we basically we were playing this inter-company tournament.
Oh,
So
okay.
for football, so I got injured in semifinals. So can't walk.
Okay, okay.
I'll
I
be
hope
there in next.
under control now.
Yeah, yeah, good, all good.
Okay, fair enough. So I'm just trying to do this from my end, folks. Let's see if it works, and then I will let you know.
Sir, this is Amit. So
Yeah.
last time for installing this pandas profiling, I used a command I have already sent in chat,
Okay.
just in the Anaconda command prompt, and it works for me.
Maybe
Maybe
we
some.
can then follow what you've done, because this is quite fresh from your uh,
I
right.
think
So
it was.
Panda installs Forge Pandas profiling. Okay, let's try
Just
it out,
this
folks.
command, if you install in the command prompt, Anaconda
Yeah,
command prompt, it should work.
in the Jupyter Notebook environment, right?
Right, right.
Yeah. So people who are working in the Jupyter Notebook environment, you can access this command in the chat, and let's see what Amit is sharing with us is working for you indeed or not. Meanwhile, I'll try to execute the same thing in the collab environment. The people who are interested in that, right? We can do simultaneously both of them.
I'm not able to get those errors which I was getting before because it's gone because it's just running in my Jupyter notebook now.
Oh,
I,
okay.
I think it was somewhat related to some package itself. You need to downgrade and then you need to make it
That's right.
equal
That's
to.
right. I remember that too. So I'm just gonna give it a try. Let's see what happens now. I have this data, cards data, and I'll walk you through. In the meantime, folks, you can do the conda install and see whether that works for you. The code that Amit shared with you. Okay, so in this case, it is not working. Right, so the Jupyter environment, it's not working. Cannot import.
This one there was basically you need to to do the markup save thing. Wait, let me. I had that code. Let me send that. Just
Okay.
I had that. I remember doing this.
Amit, after doing it in the Anaconda prompt, I just need to import it, right? Or do I need to install it again in the
No,
zip
no,
notebook?
no. Just need to import.
Okay, let me try to import it. It's getting import.
Yeah, working fine.
Yeah, it's getting import. Let me try some codes on that. So if it's giving me the data or not.
All right. So maybe in this one, in the collab environment, I think I may have another one for filing.
Yeah, so is the markup save installed in your notebook?
Not sure, but I think what I'm doing in this one, um, I'm installing a particular version of Pandas. Let's see if this was working for me very quickly. Let me run this code
It
line
was
by line.
basically what was happening is like you install certain pandas package, and then there was this markup language there, markup save, and
Mhm.
that text object that escape characters to HTML, XML. So that was causing that error. So here I guess the model is not imported for that, right? If
Mhm.
not, I'll send this thing.
Okay, fair enough. And meanwhile, I'm just trying to execute what I already have typed in from one of the previous classes. Let's see. I believe it was more about the particular version of Pandas.
Hmm.
It has a particular dependency. Nope, in this case, it's not. Ah, sorry.
Basically, if you execute that from Pandas profiling import profile report, just press enter, then it'll tell you all problems it has. Then we'll have to fix one by one for whomever it is not working.
Yeah,
Um,
yeah. I
that's
think it
one way
just
of looking at it.
yeah. Let me just restart this kernel because I think it's giving me the message. Otherwise, I'll give you a simpler code. I think there are many ways of solving the problems, like with any problem, right? I mean, but I'm just gonna talk about what I did last time to make it work, and I hope what Amit has already shared is gonna be fine with you. So I've restarted this, right? And that should work.
Did it work for Mohit? Or
It's it's throwing an error like this. I'll just copy paste in the chat. It's a type error.
Even in my case, folks, I mean, I don't think this code that I had is gonna sail through.
It's throwing me this error. Type error. Concurrent. Get an unexpected keyword argument. Join access. I
Got it.
just try to use it in Titanic dataset from Seaborn.
Hmm.
My Titanic, yeah, it's working in my system, but I can share my screen and show you.
Yeah,
Yeah,
why don't we do that?
yeah. And then, yeah, just a minute. Share my screen.
And we'll try to see if we can resolve it today. Otherwise, I'll give it some time, folks, later on, because I thought I had it figured out, but apparently there is still some challenge over here. So I don't want to
Yeah.
necessarily sidetrack the conversation, but let's see what Amin has done.
Okay.
Okay, yeah, go ahead.
Yeah. So if you see here, just Titanic dataset, right, from Seaborn, and then you're just using the same library. I think I just need to check the dependencies and the markup save and the pandas one. Then it'll work.
Sorry, say it again. I mean, just go to the very beginning. I mean, what you have installed.
So
Yeah.
this is different data set. There's the libraries, right? The pandas, numpys, and stats. This is different. If you see here from here, you have your Seaborn imported with the Titanic data set.
That's correct.
And then I'm just removing the index here. Right, just as false, keeping it as false, and then converting it into basically a CSV, because what was happening was for me directly importing the Seaborn library, the dataset itself, I was getting the same error which Mohit was showing right now.
Okay, then
Concat,
okay,
but it wasn't happening in that way. I don't know, some issue with the dataset, or I'm not sure what it is, but then
okay,
what I did was convert it into a CSV file, imported it again, and then ran the pandas. Then it worked for me.
okay. Let
And
me try that then. Okay, maybe that's the issue. Maybe that's the issue.
Okay. But you haven't spoken about how you got the pandas profiling to install correctly.
exactly. So I remember doing that in the sessions. Now
I know.
exactly. Figure out I
You
guess
did a full demo of that. I mean, you may have to just recall that. You are the ones who set it up for many of us, actually.
that's why I'm not able to recall. It was something related to the markup. I was checking the library here. I guess it was something markup save. Uh, markup save library. Yeah. So it
Got
was
it.
related to your pandas one. Pandas library. You needed to downgrade to 3.6. I think
3.6.
3.6, and there was something related to the markup save, which we were getting that error itself. And you needed to match those two libraries together because it's not workable in the latest versions,
Mm-hmm.
and so it will always throw up an error that it's not able to find that particular library to work with and to go about it. So we need to match that, as you were saying, right? So you need to match those libraries
That's
having the
correct. It's more about the version control, and whatever I had, it's slightly dated information, so that's why it's not again matching because they may have upgraded certain packages in the meantime. But we'll try to figure it out. I mean, I think let's hold on to this. If you're okay, then I'll try to see if I can get it working during the time when you're typing something else, and then we'll see if we can make it work.
let me try to find this. What
Yeah, so if you
is
can
the
just, if one of you can do this, if you can find out both for Collab and for the Jupyter Notebook, what exactly you have to do to make it work, that will be important for the class. All right, so on linear and logistics, you folks are clear, or shall we do a quick recap of what it is, and you want to do some hands-on work, or shall we go to the decision tree directly?
We have actually done both linear and logistic through examples, and that was also an exam question. So we have
Okay.
done, and that's where we learned all this precision recall and all.
Okay. So then I will move on to more important and newer topic for you. Which is a decision tree. So I would request you to, and pandas profiling, I'll come back folks either today or the next class because I couldn't make it work on my system as well, which is okay. And we'll always have some of these challenges.
Is not working actually. For how many people is not working? Pandas profiling?
For me,
Okay.
still it's getting there. I use a CSV file also.
Okay. So we'll come back to it then, just to see. And if somebody has working in both Jupyter and Colab, we'll definitely happy to see how you've done it right.
Okay.
why don't we take a break now for the folks who would like to take a break, and you can be back and look into the article number 35, right? I'll give you maybe 20 minutes for the break and going to the article number 35 from my blog. So this is a presentation where you can just click on the arrow like I'm doing. Sorry, I'll just share my screen very quickly so that you know what I'm looking at. And go through this link very quickly because this talks about the fundamental of a decision tree, what are the benefits, and so on and so forth, right? So you'll take a look over here, and then we will begin the hands-on work on it, right? And that also sort of like, will be a quick recap of some of the data pre-processing that we have done in the previous class to re-implement this on this data, right? So that's the plan. So this is 12:08. Shall we be back by 12:30 for the break? And then if you're coming back from the break sooner, then you can continue to read on it, right? Folks online, we can take this time to quickly break and then come back recharged. And then we will begin with a brand new concept of a decision tree, do some hands-on exercise. And hopefully in the meantime, we will also find a solution for pandas profiling if somebody is still giving it a try. Thank you. We'll talk to you soon.
Thank you.
Thanks.
Mohit.
Yeah, bro.
Yeah, try this thing. You're getting that concat error, right? Try
Yes.
resetting the complete index of your rather than converting into a 2 CSV, just import it. After importing it, you have your data frame. Your data frame is running, right? So
Yeah.
try to re-index it, and then try pandas profiling.
Like index will be false as you have done.
Yeah, reset it. Yeah, reset the index of that particular data frame which you're working. When you pull the Titanic data, right?
Okay. Hey, can you send me the code, please,
Yeah.
if it's okay with you?
Yes. Try this if it
Yeah,
works.
maybe. Got it. Let me run that. Second.
Check if it works.
No, giving the same error.
Oh, okay. Let me try.
It's a big headache. It's giving the error.
Okay. Wait, let me check. Try again. I think. Okay. Try which version are you using for pandas profiling? Like, what is the version you have installed?
Under profiling version, it's like the code what is provided by like it's I think uh 3.14, and it's
Fine. All
under
right.
it shows like
Just try
that.
to downgrade the pandas version. Let's see. Let me try this. Looking in the indexes because conflict. Yeah, it's working. Hopefully, come on. 90, 81, 98, 96. Okay, try this thing. In your thing,
Okay. Hmm.
try to install Pandas profiling version to 2.7.1.
To reinstall it, right?
Yeah, you just run that particular. Let me send you the code to it. It works, but my session sorry, collab keeps on crashing. Try to install this. Let's see.
Okay. It's giving some different error. No, it's saying OS errors.
Can you show me the error?
Doing it in Jupyter, huh?
Which one? Me? Jupyter is working fine for me. I'm trying in collab. Let's see.
Okay, no, I'm working in
Yep.
Jupyter. That's what I'm
File
saying.
not found in the style library. Input is not a valid URL or path use. Available list of available styles. I think it's just I think it's just a style error. It's a weird error that I mean the way we try to output the profile, right? And then it doesn't have that particular way to display it. I think that's that error. I'm not sure if I remember correctly. The available style. Let me see. see. Let me see. Okay. For me, it doesn't throw up an error. It just
Uh-huh.
it goes to 96%, and then it my collab
Right.
crashes.
Okay.
Yeah,
Okay.
that is restarted after a crashing diagnose. So, let me check this error which you are getting. So I think we're there. We're close by. Mm-hmm. 2.6 point. Okay, 2.6.0. Okay. Try uninstalling your pandas and then install your this thing. Pandas again.
Like under profiling, you are saying?
Yes, pandas profiling. Because it doesn't have that styling, I guess. That's why. Uh, if not, we'll see try to downgrade the pandas profiling, or we'll try with the latest one itself. We'll try to install. Let's see if it works. Current is this.
Yeah, it's got uninstalled.
Mm-hmm. Install it now.
By giving only pandas without any number, right?
Mm-hmm.
Yeah, wait, it's getting uninstalled. It's taking time.
Okay.
Because I have installed the latest one only, and it's giving the concatenation error. Um,
We made this work last time. So I have documented it properly.
it's taking longer to uninstall. Still running.
Let me check the dependencies, what I'm working on.
It's still running for uninstalling. I don't know why it's taking so much of time.
Okay. What pandas version am I using? Okay. My what pandas version are you using there?
Let me check. It's the latest version only.
Okay, for
I
me,
updated
I have
yesterday only.
downgraded my version to
Okay.
1.2.3. The pandas. That's where it's
Okay.
working. I'm this thing. What do you call it?
Okay.
Uh, Jup- this thing Jupyter notebook itself. I'm checking Jupyter
Mhm.
notebook dependency and what am I working in then because 2.1 markup set is 1.1. This is fine. This is fine. This is fine. And what is the dependency for pandas profiling? Okay. Okay, I'll try this one and collaborate just a minute. I want to pandas profiling I'm using is pandas 1.2.3. 1.2.3. Okay. Markup is 1.1.1.
It's working now.
It's working, right?
Yeah, it's gone up to 96%. Let's see.
If it's the same issue which you're getting in collab, like which I'm getting in collab to yours is, if then it's I think it's the packaging thing. Okay. It's
Yeah, I mean, for me, I'm getting an error.
what is
Cannot import names of Unicode from markup safe.
that you need to install the markup save library. Try to install the markup save library to 0.1. Okay, try doing that. If that doesn't work, then try with 1.1.1. That's what I'm checking.
Unable to allocate 3.7 gigabytes for an array space of this data. It's saying
You're able to see the error. For me, it crashes. Dependency currently not.
it's why it's not giving. I have a laptop of 16 GB RAM and 1 TB hard drive. I think
I have a Mac,
whatever.
but still it doesn't. But you have fallen to 0.8, which is incompatible. Why is this? I'm just gonna mark up safe. Okay, what is my pandas profiling? Which is 2.9.0. Oh, I think hopefully this works. Let's see. Mhm. Why am there is NaN values in my Titanic dataset?
Yeah, but it doesn't affect the partner profiling, right?
The auto detecting range of NaN. Mhm. Wait a minute. Let's see. Let's check this error. It's good. It's good. We're getting errors. Let's. Restart my kernel. Runtime, reset. Am I getting NaN values? What if we remove the index itself? That's what you were getting there. Because that's what that's what I'm doing here. Did it. And is it working in your Jupyter notebook? Okay. Yeah, yeah, got it.
Okay, anyone online who would like to share their thoughts on what they have gone through in the article number 35? You want to go first, Mallikarjun? Or if you're still going through it, you can take your time, but let me know if you are doing that.
Sure.
Huh?
So,
I'm good.
the pandas profiling, right? So I was looking into that thing. My
Mhm.
code is working in Jupyter without converting into a to CSV file. The reason is because in the H column, what is happening is the number is
Amin, just a second. Can you hear Sinchina? No, you're not able to hear Amin also,
We can hear, so.
or not me?
We are able to hear. Yeah. At least, I mean, we are able to hear.
Saying that she's not able to hear. Can you hear me, folks?
Even when you talk, we are able to hear.
Yes, you are able to hear.
On them, not on your side, right? Not working.
hello.
Yeah.
Yeah, sir.
No, go
So
ahead. I mean, I think there was some challenge. Some people were saying they're not able to hear me. Yeah, please go ahead and talk about that. Yeah.
yeah, so what is happening here is when you try to import your Seaborn data set, right? For example, what if I just tell you what versions I'm using in Python here?
Hmm.
For pandas, I'm using 1.2.3. For markup safe, I'm using 1.1.1. You can use 2.0.1. So
Hmm.
that works. And pandas is the latest one, 2.9.0, right? Here, when we try to import the Titanic data set, once after importing this thing, you will see in certain columns you'll find nan values, right? It's fine.
Hmm.
Pandas usually detects that thing.
Hmm.
But in the numerical column, if you see there is a nan value, so basically it's going to an infinite. So it gives you a nan comma nan that array error, right? Once I
Hmm.
drop that H column itself, that thing works. So for me, it doesn't have to convert it into a to CSV file and then import it and run that this thing's pandas profiling. It
Okay.
actually works from the Cpon, but that issue which is coming is in that column itself. It's coming that it going to an infinite number. So you are getting that histogram. You call it as what do you call range parameter must be finite. That error. Basically, you get
Hmm.
Python histogram value error.
Got it. Got it.
If we
Okay.
can try
And
with the different data set,
try that. Yeah. Hmm.
we can try with the different data set. So if we some other data set, it might work. But this reason for Titanic, it's giving that finite reason. But if you drop that particular column itself, then your pandas profiling will work.
Okay. And which column is it again?
For me, I dropped the age column because in the age
Eight.
column, it's a numerical column there, and then it has a nan values in it.
Ah. Okay. Okay. So maybe if you do the missing value treatment first, then it should work. If that is the main thing.
Yeah, could be.
Yeah. That may be the reason that it's not able to it's not able to handle the missing value. But if we fix that first in that data, we will try that when we actually do the Titanic. We'll definitely give it a try to see whether after fixing the missing value, then we can make it work actually. Yeah. Okay, great. Mohit, you have shared some code snippets there. What is that? You're talking about the error you're getting.
So that I guess Mohit is not here. He was talking about this one, sir. So when he tried to uninstall and install the pandas profiling, right? So in that particular version, there's a styling uh, error which you get. So you need to just uninstall that package and then install the pandas again because
Okay,
then that's
got it.
it.
Okay, fair enough. Yep. So we'll come to the pandas profiling again, maybe later today or tomorrow morning. Sorry, next class to take it forward. Over to you, Malkarjun. You have gone through the article 35 and you want to share your thoughts.
Yeah. Uh, I'll give gist of my understanding of all the reading over here. So decision tree primarily we are using for classification. Uh, the way I look at it is I relate to some classical example which I can think of over here. For example, in this campus, given a candidate profile, who what are the chances that the candidate get placed or does not get placed? So this finally what the decision we want to take. But then where do we start our analysis? So it could start, at least I could think of something like, given a population, you could start from, okay, is there a different branch, electronics and computer science? Based on that, you start, or you can take the toppers of both the batches, toppers versus non-toppers. Then how do you proceed? So the decision tree algorithm is basically looking at where there is high entropy, something like that, and it is start classifying, starting from that as a point. And so once it does that, for example, computer science and then electronics, the classification is done. Then it'll start looking at, okay, in each one of these things, are the toppers and non-toppers, something like that. Then there may be another parameter, for example, someone has done an extra course or not. So it keeps dividing until it reaches the final stage wherein um, whether the candidate probability of getting placed or not is arrived. So from one stage to the next stage, it is trying to reduce the entropy or information gain, some of these words that I learned. At the top level, basically, it is easy to probably classify, start from, the branch based, or it could be topper based. Eventually, what would give us a quick decision? So those are the basic things that I have understood from the decision tree diagram here. So
Got it. Okay. Awesome. Right. Anyone else? Folks online, anyone who would like to take a stab at what you have understood from this?
I think that this advantage of data decision tree, sorry, it
Mm-hmm.
actually helps and shows what actually the model will be useful in certain situations. So as you can see here, it's more robust to missing data and outliers,
Mm-hmm.
and can handle both numerical and categorical dependent and independent variables, right? So I think in that sense we understand this what capabilities of decision trees having. And
Right. Yep.
and then
Okay.
one interesting thing here is that by just looking at the final chart, it's very easy to follow what it has done, where it has started. Very human interpretable compared to what happens in linear regression, regression, where there may be a lot of equations involved over there. But here it looks like a straightforward based on a criteria. It will split the first data into two, and then it keeps splitting till it reaches the last bit. It's very easy to interpret and understand, is one thing. And we read somewhere that it could be, it could suffer from a disadvantage of, if the data changes, how good the model still is valid on a continuous changing data. So that's something little bit need to learn additionally. But those are some learnings so far.
Yep. Okay. Great. Let's cover quickly, some of the takeaways, and thank you, Mallikarjun and Amin, for jumping in. So, decision tree, first of all, is a non-parametric method. What does it mean by non-parametric? Anyone who would like to remind?
So no relationship between any of the
No
variables
particular
assumed,
relationship.
no particular
Yeah,
relationship. Okay.
relationship will be there, but no specified relationship. So it wouldn't say that, I mean, linear or quadratic or anything. So it says whatever relationship you have, I mean, I will be able to classify or do the regression on that, right? So that's one
That
of
may
the
not
main things.
be a criteria for the engine to work. Is that correct,
Correct.
sir?
Yeah.
Okay.
So it's no particular relationship. I mean, there is going to be relationship. I mean, if there is, then it will be able to detect that, but not a requirement that it's going to be a linear or exponential
Yeah.
or quadratic or anything of that nature. That's not the criteria there, right?
Okay. Okay.
So that's one thing, which is no particular relationship. That means it's a non-parametric method, right? And it's a very, very visual. So you can see from over here, right? So this is how basically a tree will be laid out. Why is it called a tree? Anyone? Why is it called decision tree?
We can see the structure of a tree, like
Yeah, looks like
probably
a
it is a
tree, right?
ultra tree, but
Correct. Yeah. So you're starting with
yeah.
the parent node, then you have child node, then you have another child node, and so on and so forth, until you get to the very last node, which is called the leaf nodes. Leaves do not necessarily grow any further branches, right? So the end nodes will be called the leaf nodes, and then in between you have basically the internal nodes, right, or the child node and parent node. A parent can be a child to somebody, and vice versa, right? So that's what basically this means. And it's a very graph-like model, and used in a variety of different settings as well, right? For because it's very interpretable, right? And there are many algorithms that we can use to build a decision tree. So, like I said, these are non-parametric methods. You can see my screen, right? These are non-parametric methods. That means there's no particular relationship between the features and the labels. What is a feature and a label? X and Y's, right? So basically, when you're looking at your independent variables and your dependent variable, there is no specified relation that we're assuming. I mean, as long as they're related, the relationship will be captured. That's what basically the non-parametric methods really mean. And they are supervised learning algorithm. What does it mean, supervised? Just I'm going by each term so that you refresh your memory as well.
You already have the known
Labels.
values, the
You
training
already
data
Yeah.
as an input based on which it will compute and able to predict something.
That's right. So you're gonna have your ground truth or your label or the dependent variable, right? Now it can be continuous, it can be categorical. That's why it can be used for both classification and regression modeling, right? So decision tree can be used for that. And we'll do example for both of them, right? That you can use the same decision tree for doing the classification and regression as well. There are many different types of algorithms which are there. Two of the more common ones are the CART and CHAID, right? CART stands for classification and regression tree. So this itself gives you the hint that I can do both classification and regression for you. And it uses the concept of impurity to minimize that impurity as it goes through the different branches, right? So we'll talk about that in a minute on what that means really. CHAID stands for chi-square automatic interaction detection, which basically uses the chi-square significance to find what splits will be more important versus the other. And then there are other versions of the algorithm like ID3 and C4 Pi and Mars and so on and so forth. I have some blurbs on that later on if you want to go through it. But in interest of time, we'll talk about the advantages first, right? So the first and the foremost is they're very easy to build, very easy to interpret. And you are building rules which are interpretable by the business. So you can take the output from a decision tree and give it to your stakeholders, and they can actually read those rules and they can make sense out of that, right? Very interpretable. They are more robust to the missing values and the outliers. So even if you don't do the missing values and the outliers treatment, missing value definitely you require, but outliers, if you don't do, that should be fine. Missing value, why you have to do it? Because sklearn library does not tolerate the missing values, right? So Amin was just talking about that. If you fix the missing values in the Titanic, then Pandas profiling is also working. A lot of packages don't like missing values, right? So just make sure that you do the missing value, but outliers you may not want to do it. It can handle both numerical and categorical, dependent and independent variables, right? So basically, type of data is not a constraint.
That's a question.
Yeah.
So what we read there, more robust missing data and outliers. So conceptually, it can handle missing data. The algorithm can still work even for with outliers, but just from the process wise, logistics wise, the pandas would require the missing values to be handled. Is that the
Correct? That's correct.
message?
Not pandas, but the sklearn library will require, because sklearn data decision tree is going to be part of the sklearn. Pandas can handle that, but sklearn insists on fixing the missing values. All right. And the fourth point is that they are white box model. What does it mean, white box model? Anyone?
So
And we are
here
giving
we already know like what is happening inside. Like in a black box, we don't know. We just have an input and an output.
Yeah.
what are the condition, all those things in the black box. But here we will know what exactly is happening inside and what the behavior is happening.
Yeah.
Based on which your input is and output is we are getting.
That's correct, Sandeep. So you know which features came out important, how much is their importance, what really has gone in your model building. All of those things are much more interpretable. In the black box model, none of those things are interpretable, and we'll be talking about some of those models later on as well, like stacked ensemble model, or you may have deep learning models where you don't know how the model was trained, what happened in the previous layer, how which variables got more importance. All of those things are a little bit unknown. They're not that interpretable versus a white box model where things are very, very interpretable, right? And we have spoken about the non-parametric, which is doesn't assume a particular relationship between the dependent and the independent variables, right? What are the disadvantages? It may overfit. How do we define the overfit? Hmm? Right. So overfitting is a problem where you have a model which does a fantastic job on a given data. But then when you give a brand new data, the model's accuracy or precision or recall will degrade, or it may degrade over a period of time as well, right? So we'll talk about that when we start to discuss the random forest, but it may have a tendency to overfit your data, right? Yeah, so hold on to that thought and we'll explain that when we talk about the ensemble in the next class. Changes in the population and the variable distribution may cause wild swings in the model performance. So that's basically instability that we're talking about. That if there is some change in the data or the variables, then it may misbehave a little bit. May favor variables which have a more levels and more categories or a bigger range. It goes after the variables which have bigger range, more categories, more levels, all of those things, right? Generally less preferred over some of the more robust methods like a random forest or some of the other things. But nevertheless, they are very, very important and everybody uses them, right? So CART, why we are using CART? CART is the algorithm that is used in the Pandas sklearn library, right? And we will use this one, and it works on the concept of impurity. So let's take a pause and just talk about what is an impurity. Um, so let's say I have a box where I have 10 balls. 5 balls are red and 5 balls are blue, right? So in terms of how the impurity is defined, let me just go and draw that picture. That is what basically the algorithm is going to try to do, right? So as I mentioned that, let's assume that there is a box or a bucket. And in this bucket, we have 1, 2, 3, 4, 5 red balls and 5 blue balls. What do you think is this a pure system or impure system? First of all, what does it mean by pure and impure?
Pure means I think there is no mix. It's like only one kind of.
I think somebody's talking online as well. Yeah. Yeah.
If the contents are skewed towards one particular category, then we say it is a pure. In a
Yeah.
sense, out of this 10, there is a 9 are red ones and then one is blue. Then say it's quite a pure one.
Right.
The impurity is very, very low because it is skewed towards one. Over here, 5 and 5, so we cannot say it is pure or impure. It is sitting at the exact half.
That's exactly right. Yeah. Okay. Somebody else was saying something. Thank you, Malkarjan.
Yeah, same thing.
Right. So now let's say we have 2 buckets and the balls are now laid out like this, right? So excuse the size of the balls. Suddenly you'll say, okay, what happened to the size of the balls? Why they have gone down? But you can imagine that we have the same number of balls, but now we have separated them in 2 different buckets. That's what the decision tree tries to do. It says if you give me a system where there is a diversity, where there is a mix of things, I would try to reduce that so that I get to the stage where I have this. Like everything is separate from each other as much as possible. This is what the decision tree really tries to do. Now, how do we measure the impurity? That's where these terms that you're going to look into, and we'll be doing some math as well, like entropy. So when you see this writing getting broken up, it's not because of my writing, but I think something happened when I connect to the HDMI, right? Or Genie. So these are the measure of the impurity. So when we say that there is system which is impure, how do we quantify that? The quantification really comes in via the metrics such as entropy and the Gini. And then you'll see that the decision tree is trying to go this path in order to lower these. And when it is lowering that, it's gaining the information. It's gaining in the purity, and that term is called information gain. We'll talk about that as well, right? So that's what basically they are trying to do. So let's look into this, how we quantify this, right? So like we discussed, impurity can be measured either in entropy or Gini, and Gini is defined like this: 1 minus summation of probabilities square, right? So I'm gonna make up a system, and I think I have an Excel file as well. So what is Gini? Gini is 1 minus summation of all the probabilities. So if there is a two class like a head and tail, and they're both likely to happen simultaneously. Let's say I have two coins. I have a coin which I flip two times. One times I get a head, the other times I get a tail. So what is the probability of getting the head? 0.5. What is the probability of getting the tail? 0.5. So 0.5 square is 0.25, 0.5 square is 0.25. So 1 minus 0.5 is 0.5. So the Gini is going to be 0.5 for that system. If I have both heads, probability of getting the head is 1. So probability of getting the tail is 0. So then Gini will be 0 because now I have two coins that I flipped, or the same coin that I flipped twice, and both times I'm getting head only. So the impurity is 0, right? Or the Gini will be 0 in that case. That's what basically it measures. There's another similar metric which is called as entropy. Entropy is nothing but probability and log of that probability on base 2 minus next probability log of next probability on the base 2, and so on and so forth, right? So let's do this example very quickly over here. So you can see this file that I have. So over here, probability of event A to be happening is very, very small, minuscule. Probability of event B to be happening is very, very high. So even without looking at the Gini and entropy, what do you make out? Is this a pure system or impure system? It's almost 100% pure, right? I mean, 99.999% pure. So it's like 100% pure system. So you can see both Gini and entropy are 0. Is that clear, people? Everyone?
Yes.
Both this Gini and entropy convey the same message, just a different formulas.
Just a different formula, yeah. That's correct.
From the interpretation perspective, I want entropy to be high, so I can also replace with the Gini to be high, something like that, for, at least in the conversation.
Yeah, sometimes it may play some role in the model's performance.
Okay.
So we will see how we choose the right metric, right? Whether we will use the Gini or we will use the entropy may have some bearing, but they both measure the same thing, right? Just a mathematical derivation that we're looking at. How about this row right over here, 0 0.5, 0 0.5? What do you make out from this? 0 0.5, 0 0.5, is this the purest or the impurest system for a binary class? 0 0.5, 0 0.5 is the probability of both events to be happening.
Is
Impurest, that's
it is
correct.
still an impure, yeah.
Yeah, Mahesh says this is the impurest because both classes are equally likely, so they're all jumbled up together, right? So that's where, I mean, this is the impurest system, and you can see entropy peaks at 1 and Gini peaks at 0 0.5. Just follow that math. Can you do that math and tell me whether you are getting this answer? What is the math? So both events are likely to be happening the same number of time. So Gini is 1 minus probability square, and entropy is this number. So can you just confirm whether you're getting that? In Excel, you can do this very quickly. And then I'm going to give you a quiz problem. Let's see if you can compute the Gini and entropy for a 3-class system. So I'll just show you the math. So what is Gini?
How do you compute the entropy? That looks a little cumbersome process there, but
No,
Gini seems
it's a
to be
probability.
easy.
It's a probability times log of that probability on the base of 2 minus next probability log on the base of 2 for that probability. I'll just do the math very quickly for you, right? So um, let's work with this problem. So as I mentioned, so there's a class A and there is a class B. Class A has a probability of 0.5, right? Class B has a probability of 0.5. So I want to compute the Gini. And if you remember, Gini's formula is this one, which is 1 minus probability squared summation, right? So let's go and look into this. 1 minus, sorry, 1 minus first probability squared, because I'm doing the summation. Then I'm going to go and look into this probability. It doesn't matter. I mean, you go in that order or you do this, because ultimately that's the same thing. And you get a Gini of 0.5. Right? What we get in the entropy, let's do that calculation. Entropy will be equal to minus this probability times log of this probability on the base of 2 minus this probability times log of the same probability on the base of 2, and you'll get the entropy as 1. Correct? Now you can change this number to anything. So let's say this is 0.6, this is 0.4, you'll get a certain math, right? Or you can say this is 0.000, oops, 0.000001, and just to save time, I will change this 1 minus to this number, and you'll see now they become 0. Practically 0, right? They are becoming e to the power minus 6 and e to the power minus 5. That means they are trending towards 0. So if you want to see what the formulas are, I'll just zoom in a little bit. So you can see Gini is nothing but these probabilities squared, right? And entropy is nothing but log probability negative of this probability. You can see this. I think that will make it easier. And then a quiz question is coming up for you. So there are 3 classes, A, B, and C, and there are total 100. So let's say we are looking at like group, right? So there are 3 different types of um, let's say let me just make extend that example. So red balls, blue balls, and yellow balls, right? So I have a bucket where I have 100 of these balls. Red balls are 25, blue balls are 30, and this is nothing but 45. So total of 100 balls, right? What is going to be the Gini and entropy? Let me just copy paste. What is going to be the Gini and entropy for this system? Sure. So I'll give you maybe 5 minutes to tell me what you think will be the right answer for this. Yeah? Entropy is 1. Gini is 0.5, entropy is 1. Anyone online? Let me know once you have the answer for this. So a bucket which has three different types of balls, red, blue, yellow, total of 100 balls. Red balls are 25, blue balls are 30, yellow balls are 45. What will be the Gini entropy for this system? What time do we take the break here? 1:30 or 2? Or it will be too late? 1:30. Some people are waiting in the lobby. No, I don't see. Gini is 645. 0.645 or 64?
0.645. I mean,
0.645. Okay.
entropy is coming.
Entropy is work in progress. Let's see if others can also confirm whether you get the same number or different number. That's for only for binary. Only for binary. For multi-class classification, it could be a different number. So Mallikarjun reports 0.645 for Gini. Let's see if anyone has a different number. You all agree once you compute. Anyone has it? Or you have a different number? Amin, Mohit, Sandeep, Who else do we have? Amit will be there or Amit left? No, Amit is not there, I think.
One question.
Hmm?
Is entropy always below 1? Or it can go higher?
Not necessary. It just
Can
depends.
go,
Yeah.
It can go higher also. Okay. 1.539.
1 point?
539. Oh.
Okay. 1.539. So
Yeah.
we have 1.539 from Mallikarjun and Sanchana. Anyone who agrees, disagrees with these numbers, or you're still working through? Purkesh, how about you? Mahesh? Acha, work in progress. Okay. Amin, are you doing? Anyone else?
A work in progress.
Work in progress. Okay, that's fine. So while you're doing this, I mean, I can start to do from my side as well. So what is it? 1 minus this divided by 100 square. This divided by 100 square. This divided by 100 square, right? Okay, so there's some typo, I think. Right, so I need to maybe do this. It's basically the order in which it's executing. There you go, 0.605, right? And then how would be this computed? That will be minus P divided by, basically this is the P that we're looking at, times log of this number on the base of 2 minus this divided by 100 times log of same number divided by 100 on the base of 2 minus this divided by 100 times of this on the base of 2. 1.539, correct? If you are not sure how we got it, you can still look into the formula and try to do it at your end just to convince yourself that that is the case.
Just did a small step also there. We started looking at the red probability, blue probability, yellow probability, and then put those
That you did,
probabilities.
yeah, which is which saves time. I'm just saying, just in terms of looking at this directly, or you could just do 0.25, 0.35, 0.45 because that's what we're divided by.
Okay. We didn't look at it as 100, so basically still try to add them up.
Yeah, so it's all divided by 100 only, so 0.25, 0.35, 0.45. Okay, so I think you typing it, Mahesh, or you got it? All good? So because you don't have to do any of these by hand, just for your understanding, right? And some other discussion about this, and we have spoken about this. So you can see how this chart really pans out for a binary class. Gini will peak at around 0.5, entropy will peak at around 1, but for more than that, it will be different.
Question on that.
Yeah.
So that's why I was looking at this one. Yeah. So it is peaking at entropy max, it is going to 1. So then the understanding here is for a binary class, this is max at 1.
That's
for more than 2 variables, so
it will be
can
higher.
go to a different.
Yeah,
Okay, that's why I was wondering 1.5 I got. Is that wrong, right? Something.
Yeah, it's only for the binary, right?
Okay.
So probably I should just say that over here. Only for the binary, this will be the pattern that we're looking at.
Okay, thanks for clarifying that, sir. Because I always thought, it is always these are the cars going to be irrespective of the number of variables. Okay. All right.
And then the question is, if it can do the regression as well, what will be the metric that it's going to use for the regression? Huh? That's correct. So it will be using the mean square error or mean absolute error for doing the regression related job. So for the classification, it will be looking into the Gini and the entropy as the impurity measure. For doing the regression, it will try to minimize where it will try to come out with the nodes where it is going to minimize the mean square error or mean absolute error as it proceeds forward. Right. So that's the difference between a regression and classification, because it can do both. Right. So how would it do the regression? How would it do the classification? Basically, for regression, because there's nothing called as impurity, right? It is error that we have defined for the regression. So that's what it's going to minimize. That's how it will do it for the regression, right?
Sir, one question here. See,
Yeah.
this MSc, MAE, they were almost the model diagnostics, right? But here we are also talking the impurity function.
That's correct. Yeah.
Okay.
They are the impurity function even for your regression, like a linear regression when you're doing the sklearn.
Okay.
That's what it's trying to minimize, right? When it is building the model, it is trying to optimize for that error or minimize that error that we're looking at. Same thing over here. It is saying, okay, I'm going to minimize this error. So if I'm going from one node to another node, I will pick those nodes, which basically gives me the bigger reduction in the mean absolute error, right? We cannot hear you, I think.
Oh, sorry. If you can say this way, for the classification problem, the impurity function it is going to look at is entropy and Gini, and then the model diagnostics for that is still our confusion metrics and accuracy, precision, and recall. Whereas for the regression problem, so the impurity function is MAE, MSE, and also model diagnostics are going to be in terms of MAE, MSE.
That's correct. That's exactly correct. Yeah. Any questions, class, on these? Okay. How does a decision tree really work? Anyone who would like to explain me this slide? Let's see if there's a volunteer who understood the entire flow and can help me understand how a decision tree really grows.
Before that, I had one question.
Yeah.
On the boxes example.
Which one? This one?
The one which you drew on the screen.
Oh.
The red balls, green.
Okay, yeah. Let me just pull it up. Yeah.
See, over here, this is the only problem that we have just to classify them. So it's very easy to start by coloring as the first node probably, and then split based on the color. But I was wondering if two of the red circles were triangles and three of the blue circles were triangles, then there could be an option. First, I'll choose the triangle and circle based classification, then resolve into red and blue. Or I'll start with red and blue classification, then I'll resolve into triangle and circle based classification. So is the model looking at those the impurity and the entropy and Gini to arrive at where do I start? It probably starts with both and then see where the information gain is maximum or the entropy is high or low. Based on that, it will start taking decisions. So I have some basic flow that's running in my mind. So it can you can.
It all depends on how your data is labeled. So if you say that my data has triangle and circle shape, for example, defined, or triangle, circle, and rectangle shapes defined, that is how it's going to split. Okay. Or if you say my data has a red triangle, yellow square, blue rectangle, and all the mixes in between.
Not exactly that, sir. So my question is, so I have red, green, and then triangle and circle, four label data. So under red, I'll take five of them, right, and the others are zero. Under blue, well, okay, it could be two types of labeling over there. Assume, so we are using both of them, red column and the blue column. So here five was true and here five are true. The rest are zeros. And then the triangle, so some five are zero, some others are one, and so on. So it could be a mix of red true and triangle true, but others are off. So that kind of a data is what is given to the model. So where it will start picking from. It can start from both
depends on
color
how
based.
Yeah, I mean, you can combine those into one dependent variable, similar to what we're discussing
Okay.
earlier on, right? So you can say, I mean, I can create a brand new dependent variable or the label, which is going to incorporate those different things that we have into one, and then you can put that in a decision tree. But if you have multiple label columns, it won't work. You have to pass on one single array, which is your dependent variable for a decision tree. So that's a limitation. You cannot have like many columns to be passed on as your label. It has to be only one. But you can do your internal feature engineering to create that label yourself and then pass it on to the decision tree. It will be able to pick it up for you, but not the multi-class label.
So here, if you solve this problem, it will only segregate greens and reds,
Right.
based on some criteria.
Correct.
Or it can be triangle and circle.
Or you can define another dependent variable, like I was saying, that you can say green triangle, yellow triangle, blue rectangle, right? And just have that, and it will be able to pick it up.
Oh, so the final dependent variable has to be one.
Yes, correct.
Okay, then
For
it
this,
can.
yeah.
Okay.
For this decision tree method to work, yeah.
Okay.
Only one.
Okay.
Great.
This is again similar to logistic so-called
It is
regression.
similar to logistic, but it's
Just
more
a different
robust because
engine and approach will be different.
right. It is similar, but it's more robust because it's non-parametric. That's the main
Sure.
thing.
But in terms of the final outcome and also over there, it is the true or false. Here also it will be true or false,
Exactly
and then
right.
it are alive.
Yeah.
Okay.
Yeah.
Okay. Right.
You will see it once you do a couple of demos that it's not very different from how a logistic regression would work. The only thing is that for your non-linear data, it may provide you a better solution.
Okay.
Great. I know we are almost getting to the lunch time, but anyone who would like to quickly explain this slide?
Yes, sir.
Yeah, go ahead.
Yes, so basically, as we understand how the splitting of classes is working in decision tree, right? So that's what's happening in the first part, where you have the split of different classes, and then once the split of each classes from your parent to your child node, then we'll understand the part where we have this information gain, right? So where it class each of your information gain, which we have here, tries to have the maximum thing from each of the classes there. And once that is done, we'll as it keeps going down, we'll try to figure out like less impurities there in each of those classes of those child classes. And then when it has that maximum split of those each of those nodes, which you can see here, then we have this hyperparameters as well, which basically, as we know that it's a non-parameter in decision tree here, right? So it'll basically we can say that uh, basically we don't determine the what you call the basic how do you put this, basically we don't know that what kind of inputs we have because there's no relation and stuff like that. But as we keep on going down and it keeps on splitting the data, we try to increase the information gain and reduce the impurities. And then you have this split there where we know that in non-parameters it will try to overfit the model, right? So we'll try to do a hyper parameter recognition as well there, right? So it doesn't overfit the model. So that's what the entire process would be, right? Initially, you'll have the splits from your parents to your child nodes, and then you'll have the final stage of leaf, right? And there we'll try to obviously have that information gain, and the higher the information gain is, the clear the picture is that it's defining that particular class, and then it tries to reduce the impurities, and then when it goes to that point of stage where it's trying to overfit the model, we'll try to regularize it. That's what my thought process is from this.
Okay, fair enough. Yeah. So I think one of the things that it is going to do is to look out for the opportunities to maximize the drop in the impurity. Maximize the drop in the impurity is nothing but synonymous with gain in the information. That's why the term is called information gain. So it will look out for those features, look out for those cuts in the features internally. So it will evaluate all the features and it will say, if I break it by this, This is the drop in the impurity I get. If I break it by this other feature, this is the drop I get in the impurity, right? And it will choose the feature and the split where the drop in the impurity is the highest, right? Because that's the efficient utilization of the resources. It will choose where it is able to drop the impurity the highest. That will be the feature and the values of the feature that it will choose to split the node. And then information gain is nothing but, let's say you have a parent node, it will be split into two nodes. Always get split into two node. So what is the impurity in this? What is the impurity in this? Do the weighted average. Weighted average meaning, I mean, you have to weigh for the number of samples you have and then subtract that, and that is the information gain. And it's trying to optimize and maximize that information gain, right? And it will continue to do until it forms a purest node. So that's why it's called the tree will grow very, very wild because the branches are going in all the directions and all of that. So that's why there are strategies which will help us prune the tree. And there are strategies which do the pre-pruning before you develop the tree. And there are strategies which will do the post-pruning after you've grown the tree to really make sure that you have the optimized performance. We'll talk about that as we come back from the lunch, right? So when we come back from the lunch, we will begin with the actual hands-on demo, and then we'll interpret the output of the tree. And then we will come back and see if something that doesn't make sense to you. But we will begin with if people are not going for lunch online, you can start to do what is there in article number 34. This is not going to be a classification model at all, but just visualization as of now, how we are actually doing the visualization of the tree. So there are some details over here that you should go ahead and type it out, article number 34, just on the iris data, nothing else but the iris data. And then we'll come back and then we will start to follow what we have in the same article, article number 35, and work on this hands-on example on Titanic data. Will that work? Okay, that's it, folks. Sinchana, the time for the break is how much? 40 minutes? 45 minutes? 45 minutes. So it's 1:30 people. Can we be back by 12:15? Yeah. Sorry, 2:15, not 12. We're not doing the time travel, 2:15. Okay, let's be back by 2:50 and then we will continue from there. And if you are not taking a break or if you come back sooner, just begin with the article that I mentioned, which is the article number article number 34. Yeah, article number 34. So just begin there. Yeah. And then we'll come back and talk about that. Thank you. Take care. Folks online, can you please confirm if you're back?
I'm back, Sandeep here.
Okay, great. How about Mohit,
Yeah, back.
Shashikala, Amin?
Back, sir.
Okay, great. So if you are back and you are good to go, let's go ahead and type in the article 34. You may have to install this package, which is called the Graph Viz, but let's take this moment to start typing in and see how much progress you can make. So it's the same blog link, but go to article number 34 and you'll see this tree that we have drawn using Iris dataset. So that's what you're going to try first. So just pause. You don't have to type the remaining code just until you get this graph on your screen and on the Iris data. That's the ask. Yeah. You will have to definitely install this package called GraphViz. But if you're in a Jupyter Notebook environment, then you may not have to. And while you're doing this, I'll just try to run it very quickly from my end just to make sure it's working fine. But you don't have to wait for my screen. You should work with the link that you have there. So we should take maybe in 15 to 20 minutes just to really make sure that the code is working, and then we can come back and interpret what we have.